Hi everyone, my name is Diego Pinlac and today I'll be presenting my machine learning term project about forecasting employment trends in Canada using demographic and labor market data. So as we all know, employment changes a lot depending on the economy and industries. And the problem is it's very hard to understand trends just by looking at the raw data, right? So for this project, I actually used machine learning to learn from past data and, predict the future employment. I used data from Statistics Canada with over around 400,000 data or rows and 16 columns, which includes year, province, industry, and employment values. And of course, before modeling, I actually cleaned it and structured the dataset. The pipeline is very straightforward. I did some data cleaning, feature engineering, temporal train test split, and then modeling. For the models, I actually used linear regression and decision tree, and of course, the goal is to predict 2026 employment. So now I'll quickly walk you through the notebook. So this is my notebook. I just have a quick introduction, like what the project is about, the problem, and the overall steps I followed. And then here, I just imported all the libraries like pandas, numpy, etc. And also I imported the functions I did from my helper, which is this file. So yeah. And then here is, or I load the data set and check things like shape and missing values. And based on this, it has around 434,000 rows and 16 columns, which is pretty large data set. And then moving forward to the data preparation and transformation, here I clean the data set and transform it into a usable format. So I just basically kept the important columns like year, province, employment or employee type, industry and employment. I renamed some of the columns and removed rows with missing employment values. I also extracted the NICE code and industry name. So instead of having everything in one column, I split it into a structured features. So now moving forward to the EDA, I actually created three different charts to understand the patterns. So this line chart shows employment over time for Canada. So as we can see, the employment generally increases from 2001 to 2025, but it's not perfectly smooth as there are some dips here. Next is the employment by province. As you can see, Ontario, Quebec, BC, and Alberta clearly dominate, which means that geography plays a big role in employment patterns. Lastly is the employment by employee type. So all employees is the biggest category, but salaried and hourly workers also show a different patterns. So with all these charts, EDA actually confirms that time, geography, and employee type are all important features. So this is one of the most important parts of the project, which is a feature engineering for forecasting. I actually created um, lag features, which is this, the rolling averages, and the growth rate. Basically, I'm giving the model historical content or context, which is important for forecasting. And the next is the train test split. So instead of random splitting, I actually used a temporal split. So I trained the model from 2004 to 2022 and test it from 2023 to 2025. Why? Because this avoids data leakage because we don't want the model to see featured data, right? And then here I build the model. So I actually used linear regression and decision tree um, model. And then this is just a comparison between the linear regression and decision tree um, regressor. So with regard to the model performance, I evaluate the models using metrics like RMSE, MAE, R squared, and MAPE. Accuracy is not used here because this is a regression problem. So as you can see here on this chart, so scatter plot shows the actual versus predicted values. If the points are close to the line, it means predictions are accurate. While in the residual part, it shows the errors. So ideally, they should be randomly distributed. So with that, linear regression performs better with lower errors and higher R squared, meaning it explains the data better. Next is the year-by-year performance review. Here I evaluated the performance per year. So instead of just overall results, I checked 2023 to 2025, and it shows, that the model performs consistently well and actually performs best in 2025 because it has the smallest errors among the three test years. So lastly and the most important part, I generated predictions for 2026. So as you can see here, the model estimates around 18.2 million employment in Canada, but this is just a prediction, not an official data. So with all this, let's move forward to my project utility file, which is this. I created this helper file, which basically contains the reusable functions like data preparation, model building, evaluation, and forecasting. This is just to, keeps the notebook cleaner and more organized. So this function basically reads the CSV file. This temporal split basically splits the dataset into training and test. And then this is the linear regression. So I am using a one hot encoding, while for the decision tree, I am using an ordinal encoding. And then regression metrics is basically, instead of just doing the formulas over and over again in the notebook, I just made one function for it to calculate the RMSE, MAE, R squared, and MAP. And then lastly, of course, is the prediction. So with this, what it does, it takes the latest available data from 2025 and creates a new feature frame for 2026. So it fills in things like year, the lags, and then it also recomputes rolling mean and growth rate, which is this. So basically, the function prepares, the input data needed for the model to generate the 2026 forecast. So yeah, this project follows, the full machine learning pipeline from data cleaning all the way to prediction. And the result shows that historical features works well for forecasting and linear regression perform best. So yeah, that's my project. Again, my name is Diego Pinlac, and thank you for listening.